Absolute value equations. First of all, one thing that we need to appreciate about absolute value expressions, which is what makes these equations hard, is that we really can't move any terms in and out from this absolute value. For example, in this first one, there's no way that we can combine this plus 2 and the negative 5 because the plus 2 is inside the absolute value, the negative 5 is outside. So there's no algebraic simplification that we could do here that would allow us to combine these or simplify this expression in any way. Same thing for this equation 2x minus 1 inside the absolute value equals 3. It's not legal for us to simply add 1 to both sides of the equation and get the 1 out of the absolute value in doing this. So both of these are just examples of something that we can't do so that we can understand why it is that we need some new tricks for working with these absolute value expressions when they're inside an equation. If we're taking an absolute value of a numeric expression, we know that we would just replace negative values with positive ones. But once we have a variable inside that absolute value, everything is much more complicated because x could be positive or x could be negative, so there's no other way to simplify or just write this expression as an equivalent expression without the absolute value. So what we're going to do instead is establish a pattern that we can follow for solving absolute value equations. And we're going to do that with these three simple equations right here. First of all, the equation absolute value of x equals 5 has two solutions, and we're asking what are they? If you think about it for a moment, what numbers could you plug in for x here and get a true statement? Certainly if x equals 5, that seems like it should work because the absolute value of 5 equals 5. And it's also true that if x equals negative 5, then when we plug that value in, we would take its absolute value and get positive 5. So we have two solutions to something in this form. The equation absolute value of x equals 0 has only one solution because 0 and negative 0 are really the same number, right? Both of them are just 0. And 0 is the only number whose absolute value is 0. Finally, the equation absolute value of x equals negative 5 has no solution. We want to think about why that is. If we imagine trying to find a number we could plug in for x and take its absolute value, after doing that we should get a positive number or 0, so at least certainly a non-negative number, which means it's impossible for this equation to be satisfied. So this has no solution simply because the absolute value is always positive. So what we're going to do when we solve an absolute value equation is first categorize it as one of these cases. Is it equal to a positive number, in which case it has two solutions? Is it equal to 0, in which case it has one? Or is it equal to a negative number, in which case it has no solution? So here's our rule. Our rule for solving is that if our equation is of the form absolute value of f of x equals a, where a is a positive number, then we set up and solve these two equations, f of x equals a or f of x equals minus a. We're just using the f of x here as a placeholder to say this could be any expression, and whatever that expression is, we're going to use it twice. So it works better in an example. If we look at this first example, absolute value of negative 2x plus 3 equals 7, we see that 7 is positive, so we're going to follow this model and set up two equations. These equations do not still have the absolute value in them. This is the whole point. My first equation would use positive 7, and then I put an or, and my second equation uses negative 7. So the only difference between these is positive 7 in the first one, negative 7 in the second one. This is what allows me to get the expression on the left-hand side outside of the absolute value. By breaking it up into these two separate cases, we say we have now considered every possibility. Once we've gotten the equation out of the absolute value, then we can go ahead and just solve it using our old techniques. So this becomes negative 2x equals 4. Divide both sides by negative 2 to get x equals negative 2. The second one, subtract 3 from both sides. We get negative 2x equals negative 10. Divide both sides by negative 2 to get x equals positive 5. It's very important to note here our solutions did not come out to be the same number but with opposite signs. If there's anything else going on in this other than just a simple x, or maybe x times a number, then you are not going to get the same value with opposite signs. So you absolutely do have to solve both equations. It's a fairly common mistake for students to just solve the equation once and then put a plus or minus in front of it thinking that they have now accounted for the absolute value. But no, as we can see, you get two totally distinct solutions. Going on to the next one, we want to first isolate this absolute value. So I'm going to get it alone on one side of the equation before I can follow this model, because our rule says it has to be of this form, absolute value equals a number. So when I add 5 to both sides, that gets me 3 times the absolute value of x plus 1 equals 9. And then I divide both sides by 3 to get the absolute value of x plus 1 equals 3. At this stage, I am ready to go ahead and break this into two separate equations. X plus 1 equals 3, or x plus 1 equals negative 3. I definitely would not have gotten the same answer if I had tried breaking it into two separate equations in the very first step with that 4 on the opposite side of the equation. So we have to completely solve for the absolute value first. Of course, these are very easy to solve. We end up with x equals 2, or subtracting 1 from both sides here gets us x equals negative 4. So our two solutions are 2, negative 4. Making sure to use roster notation here. Don't put those in parentheses. Parentheses mean ordered pair, or else they mean the interval from 2 to negative 4. So it has a very, very different meaning if you use a different kind of brackets. Curly braces are good for roster notation here, which is just listing two values.